Welcome to the video lecture by Dr. Biju Vasudevan for the course Calculus 1 Math111 for JUC students. In this video lecture, we are going to discuss chapters 3.1 and 3.2 for week number 9. We are going to solve some problems with all possible steps from these two topics. Here we go. Now the first chapter is 3.1, which is implicit differentiation. So here first we will see what is an implicit function. An equation in the form y is equal to f of x is said to define y explicitly as a function of x because the variable y appears alone on one side of the equation and does not appear at all on the other side. However, sometimes the functions are defined by equations in which y is not alone on one side. For example, we can think of this function yx plus y plus 1 is equal to x. So this is an equation in which both y and x involved. This is called implicit form. Now we have to find the explicit form from this one. That's it. We can take y common from the first two terms. It is y into x plus 1, and this x, positive one on the right side is x minus 1. So now y is x minus 1 over x plus 1. This is called explicit form, isn't it? So in this case, we know in the case of explicit form we can find dy by dx by using the quotient rule. By using quotient rule, you know how to differentiate this one. But if I give you this form, the implicit form, how to directly find the dy by dx without changing into explicit form? That's what we are going to discuss in this chapter, right? And you know there are some equations in x and y that can implicitly define more than one function of x. For example, if I give you an equation like x square plus y square is equal to 1. What do you mean by this implicit? This is an implicit equation. So we can find the function here now. Y square is equal to 1 minus x square. So y is equal to positive root of 1 minus x square is first function, negative root of 1 minus x square is another function. So when we draw, this is a circle actually whose center is origin and radius is 1, isn't it? So first part gives upper circle, second part gives lower circle. Separately they are functions of x, but together they will not satisfy vertical line test. So together this is not the function of x now, isn't it? So in this case we are going to find the dy by dx of these functions directly without converting into explicit form. That's what we are going to do this one in this case. Let's go to the exercise set 3.1. What we are going to do to find differentiation implicitly. So first, there is a given problem from this exercise set 3.1. The first problem is square root of y minus sin x is equal to 2. Find dy by dx by differentiating implicitly. Next, write the function y as a function of x. Find dy by dx and check both the equations whether two results are same or what. That's what we are going to do here. Right. First, implicitly differentiate this one, part A. Differentiate y with respect to y. So what do you get? This is actually, we can write y to the power half minus sin x is equal to 2. Use power rule first, and y half to the power half minus 1 and then whenever you differentiate y, remember that y is dependent variable and x is independent. So when you differentiate y, you write a new term dy by dx. Whenever we differentiate y, apply the differential rule for this one power rule and then differentiate y with respect to x. Next, this is just a function of x alone, so differentiate it with respect to x. When you differentiate sine, you will get cosine x. In the right hand side it is 0. Now simplify this equation number 1 and get the value of dy by dx, isn't it? So when you write the first term, it will be 1 over 2 into root y, and then dy by dx. In the right side it will be cosine x. You understand how this becomes this term 1 over 2 y to the power negative half. So it is 1 over y to the power half. So power half is square root, isn't it? So you get this term. Therefore finally what is dy by dx, which is multiply this one 2 times root y into cosine x. And if you know the value of the function y, from this one we can get root y, and let this be our result a. If we don't know what is y, we can keep it here a, and then we can check with the other answer, isn't it? Okay, let's go. Remember this answer a, and we will compare with the second result b. Okay, note down this one. Second part, actually I'm writing the first part result here. Dy over dx is equal to 2 root y cosine x. This is our result a. We call it a. Now part b, convert this equation as y to the power half is equal to 2 minus sin x. We are converting into explicit form. Now square on both sides, therefore y is equal to 2 minus sin x whole square. Now differentiate both the sides with respect to x. Dy by dx using power rule, 2 into 2 minus sin x and to the power 1, and then differentiate term by term by using chain rule. This is 0 minus derivative of sin as cosine minus cosine it's cosine. Yes, of course, should have been positive sign, because the given is y power half minus sin x is equal to 2. So when you take negative sin x to the right, is positive sin x, so it should have been positive here, and everywhere it is positive. So the answer is 2 into this term is root y, isn't it? Root y. So we know we have to, this will give you root y is equal to 2 plus sin x. So this is 2 times 2 plus sin x into cosine x. This is actually dy by dx in case b. You know this equation a and b are same. When you replace root y by this formula, 2 plus sin x, this rule, take this one, substitute the root y value here. So this is 2, root y is 2 plus sin x times cosine x. So the a and b are same. The results occurred by method a and b are same. So we got it. That's it. Confirm that part C is confirm that the results are consistent by expressing the derivative in a as a function of x alone. When you convert everything into x, they are same. So now let's go for the next problem. Find dy by dx by implicit differentiation. So how we perform the implicit differentiation? Generally again we are going to repeat for these two problems. Let me choose one problem and the rest is your problems. I will choose problem number. Both are almost equal, so you can choose 4. Differentiate this one on both the sides with respect to x. So x cube, when you differentiate with respect to x, it is 3x square. When you differentiate y cube, we should remember the chain rule. Y is a function of x, So this is 3y square, and whenever we differentiate y by implicit differentiation, we should write dy by dx. The right side 3 is a constant. Now use product rule. For xy square, this term use product rule. Keep x, differentiate y square, you get 2y and dy by dx. See, for simplicity we can use dy by dx as y prime. It could have been easier to use the notation. Now by product rule, what we know, first we kept x and differentiated y square. Next we keep y square, differentiate x with respect to x is 1. Now simplify and find dy by dx. Take the term dy by dx to the left side, keep everything else in the right side. What you are gonna do next is this 3y square dy by dx, the second term has been kept in the left side. The first term in the right side, 3 times x, this term, this 3 into this term will be in the left side, minus 3 into 2, 6xy dy by dx, and there is 3y square on the right side. This 3x square will join here, 3x, and 3 is a common term. You can divide by 3 and take dy by dx outside, dy by dx. So this term will be y square minus 2xy, the coefficient of dy by dx. This 3 has been divided, this is negative 2, and then xy, y square here, dy by dx is common. On the right side it is y square minus x square. Therefore dy by dx is y square minus x square divided by y square minus 2xy. This is the end. Now this problem number 4. Try problem number 5 in the similar way. Whenever you differentiate any term involving y, right, first differentiate the term by using normal rules and then write dy by dx. That is what you should remember for implicit differentiation. Let's go for the next type of problems. Finding second derivation. I'll choose one problem, obviously. There are 2 more problems, I think. 8 and 10. So let me choose one of them. Again, we are supposed to find only this is coming under the same topic. Find dy by dx. So we are going to find only dy by dx, which is y prime. That's my question, isn't it? So I solve problem number 10 or 8. What's your choice? Let's go to 10. The first one is easy. In the left side just 2x, right side you use product rule, I mean quotient rule. But whenever you differentiate y, make sure that differentiate y with respect to y and then write dy by dx. That is it. Let me try problem number 10 here. This is cosine x y square is equal to y. First chain rule on the left side, differentiate cosine. What do you get? Minus sine xy square, and then differentiate xy square by using product rule. The inner term by using chain rule. That is x has been kept, differentiate y square, 2y into y prime. Y prime is dy by dx, remember it. Plus keep the y square, differentiate x, you will get to 1. And on the right side, when you differentiate y, it is 100 dy by dx. That is y prime. Now simplify and get y prime. That is our aim. We are going to find dy by dx, isn't it? So what is this? Multiply everything inside now. Minus sine x y square, multiplied with the first term, it will be 2xy into 2xy y prime, plus again minus y square sine xy square is equal to y prime. This y prime comes to the left side. So what do you get? minus sine xy square into 2xy y prime minus y prime. This term in the right side is a positive y square sine xy square, isn't it? Now take y prime as a common term from the left side, minus sine xy square into 2xy minus 1. Commonly taken as y prime. So right side y square sine xy square. So the next step we get y prime. So I'm writing the solution here. So y prime in the left, in the right side numerator is y square sine xy square. In the denominator it is negative sine xy square into 2xy minus 1. That's it. That's the end of this problem. Try problem number 8 in your own way. Next, we are going to find second derivative for any one of these three problems. Let me choose. Obviously, the first one is going to be very easy, isn't it? Second one, let me try 16. We are going for second derivation. Actually, first find first derivation by using implicit differentiation. First term 6y needs product rule. Differentiate, keep x, differentiate y, it will be 1 into y dy by dx y prime, plus keep y and differentiate x with respect to x, it's 1. So xy prime plus y. Next is differentiate y square, it is 2y, and whenever we differentiate y, we should write dy by dx, which is y prime. The right side it is 0. So find y prime from this one. Here there is a y prime, here there is a y prime. When you take y prime as a common term, you get x plus 2y, and this y in the right side it is a negative. The right side is negative, so it is negative y. Therefore, what is y prime? Which is negative y over x plus 2y, x plus 2y. Okay. Second derivation, as usual, use quotient rule. We are going to do the second derivation here. Y double prime, which is by quotient rule. First keep the we should remember the quotient rule. U over v whole prime is v u prime minus u v prime divided by v square.